Good morning all and welcome to Mars. The time is 12:50 hours, standard Martian time, the month is Kumba, and the day is the 15th. Ambient temperatures on this beautiful day around the equator are a balmy 20 degrees Celsius. If this is your first time to the Red Planet, congratulations on booking accommodations that coincide with Martian spring. Yes, that means that the dust storm season is now behind us, and we can all look forward to the many sunny months ahead. It also means that those who have booked the Red Planet Adventure Tour will have the chance to conduct surface walks with clear and unobstructed views of the Martian surface. Perhaps someday soon, people could be traveling to Mars regularly in the same way tourists travel to different countries. Those visiting the Red Planet might even be treated to messages like that. The idea that humans may one day travel to Mars and create an outpost of civilization there has also been enduringly popular. Today we are getting close to the point where human-rated missions to the Red Planet are possible, which has led to a renewed interest in creating permanent settlements there. Today we are looking at Earth's twin, the fiery red planet known as Mars, and ponder the question, could humans really survive on Mars? Astronomers often refer to Mars as Earth's twin because of the similarities this celestial neighbor has with Earth. For starters, it is the second most habitable planet in the solar system, at least by our standards. Like Earth, it has polar caps, evidence of surface and subsurface water, a daily cycle that lasts close to 24 hours, and a tilted axis that causes seasonal variations. Beyond that, the contrasts between our two planets are pretty extreme. Mars is an extremely cold, desiccated body with a very thin atmosphere compared to Earth. Its surface is drier than the driest deserts on Earth, water can only exist on its surface in ice form, and the level of irradiation it receives is enough to kill off most species of terrestrial plants and animals. Yet humans could establish a permanent human presence on the Red Planet with the right kind of hard work and technology. And with a lot of hard work, the planet could be ecologically transformed, aka terraformed, to the point that it could be Earth's twin in just about every sense of the word. Unlike Earth, Mars has no planetary magnetic field. On Earth, this field is believed to result from action in the planet's interior. This consists of the molten outer core revolving around a solid inner core, which creates a dynamo effect that generates a magnetic field. According to multiple scientific investigations, Mars had a magnetic field about 4 billion years ago. However, its lower mass and density caused it to cool faster, leading the outer core to solidify while the inner core remained molten. This arrested Mars's interior dynamo effect, and its magnetic field disappeared. Consequently, Mars's once dense atmosphere was slowly stripped away by solar wind over the next few 100 million years. While it is replenished by outgassing, the atmospheric pressure today is less than 1% that of Earth's. And what little atmosphere it has is a toxic plume, composed predominantly of carbon dioxide, argon, and nitrogen with traces of methane and water vapor. The atmosphere is not only unbreathable, but also incredibly thin. Measured on the surface, the air pressure averages about 0.636 kPa, roughly 0.6% of Earth's at sea level. And whereas Earth's atmosphere is composed of 78% nitrogen and 21% oxygen, Mars's atmosphere is a toxic plume composed of 96% carbon dioxide, 2.6% molecular nitrogen, 1.9% argon, carbon monoxide, and water vapor. Because Mars is about 50% further from the Sun, it receives much less solar radiation and heat from our Sun. Another factor is Mars's thin, tenuous atmosphere, which cannot absorb much heat from the Sun. As a result, the average surface temperature on Mars is a frigid minus 82 degrees Fahrenheit, but this ranges considerably based on location and the time of year. During a Martian summer, temperatures can reach as high as 95 degrees Fahrenheit around the equator at midday. During winter, temperatures plummet to as low as minus 233 degrees Fahrenheit in the polar regions. But even when temperatures are at their warmest, the very thin atmosphere ensures that most of the heat is just lost a few inches from the surface. To illustrate, if it were possible for a person to stand naked on the surface of Mars, their body would feel some severe temperature differences. While sand would feel very warm beneath their toes, everything above their ankles would be freezing. Above the waistline, temperatures could get low enough to freeze them cryogenically. Then there's the small matter of all the radiation people would be exposed to. On Earth, human beings in developed nations are exposed to an average of 6.2 MSV per year. Because Mars has a very thin atmosphere and no protective magnetosphere, its surface receives about 244.5 MSV per year, more when a solar event occurs. NASA has established an upper limit of 500 MSV per year for astronauts, and studies have shown that the human body can withstand a dose of up to 2,000 MSV a year without permanent damage. However, prolonged exposure to the kinds of levels detected on Mars would dramatically increase the risk of acute radiation sickness, cancer, genetic damage, and even death. Dust storms are a regular occurrence on Mars and happen whenever the lower atmosphere heats up, causing air currents to pick up dust and circulate it around the planet. This can occur when Mars is at the closest point in its orbit to the Sun and can also be exacerbated due to variations in temperature between the hemispheres, i.e., when one is in summer. At times, dust storms on Mars can grow to the point that they encompass the entire planet. These are known as Martian global dust storms, and they occur only in the latter half of the Martian year. Other than that, dust storms are temperamental and happen with every passing dust storm season, which coincides with winter in each hemisphere. And then there's the matter of Martian gravity, which is roughly 38% that of Earth's. While scientists do not yet know what effects long-term exposure to this level of gravity would have on the human body, multiple studies have been conducted into the long-term effects of microgravity, and the results are not encouraging. This includes NASA's seminal twin study, which investigated the health of astronauts Scott and Mark Kelly after the former spent a year aboard the International Space Station. In addition to muscle and bone density loss, these studies showed that long-duration missions to space led to diminished organ function, eyesight, and even genetic changes. It is fair to say that long-term exposure to around 1/3 of Earth normal gravity would have similar effects. Like astronauts serving aboard the ISS, these effects could be mitigated with a robust exercise and health monitoring regime. But the possibility of living under these conditions and children being born in them raises a whole lot of unknowns. An absolute must for missions destined for the Moon, Mars, and other destinations in deep space is the ability to be as self-sufficient as possible. This is known as in situ resource utilization, and it entails using local resources to provide the necessities like propellant, oxygen, water, building materials, and energy. For starters, much of Mars is covered in silicate mineral dust